Okay. So like we said before, we're doing section 2.10. This is all about adding and subtracting fractions. So you guys excited for that, huh? Okay. First of all, we're going to begin by adding fractions that are like each other with pictures. Okay. So we're going to add like fractions. And we're going to start with the mid-level of abstraction, pictorial, okay, which means that we will diagram our addition problem. And I'm going to go ahead and do this with just pictures because they're kind of basic and because the fractions are like each other. And so just to give you an idea about how pictures will work with fractions, I'll use these as models. So first we're going to add 3/8 and 1/8. Okay. So we need to depict, in addition with fractions, you depict each of the fractions with a bar. Okay. You can also do circles if you want, but we're not going to, just to kind of keep our representations consistent, we won't do circles. We'll just do bars for right now. Okay, so the first fraction is 3/8, and I want to divide my bar into 8s. So what I can do is I can divide the bar in half, and then divide each of those halves in half. Now I have 4ths, and I divide each of those halves in half. Okay, and I have 8s, and they're fairly spaced equally. Sorry, they're spaced fairly equally across the bar. And I'm going to do, let's do a light blue. I'm going to depict 3/8 by shading 3 parts, each of which of these is 1/8. Okay. When you're adding fractions, again, the second fraction is depicted with a bar. Okay, so I'm going to label this as 3/8 here. This bar, I'll draw the same size because they have the same hole. 1/8 and 3/8 need to be like each other in that they have the same size hole and the same size pieces to add them together. Okay, so since they are from the same hole, we will draw the same hole like that. And they are the same size pieces. So we'll go ahead and we can go ahead and draw this pieces the same size. Okay. Halves, and then 4ths, and 8ths. Okay. I'm going to draw 1/8 here. Okay, so shade one of those parts where 8 copies of it make the whole. That's what 1/8 means. One part where 8 copies of it make the whole. When we add them together, we're combining the values, just like we did with whole numbers. We're combining them. And so to indicate the combining, I'm going to put this 8 up into this one right here and combine it with my 3/8. I can indicate that with an arrow. Okay. And then I'm going to draw a new bar for my answer. Okay. And in my new bar, I have all 3/8 and my 1/8 make the 4/8. Okay. So we're going to make 4/8 here. Okay, so here's my 4/8. And what I'm going to do is simplify, because whenever you add things together, add or subtract, you simplify. When you operate on fractions, you simplify. And simplification with the picture means that I'm grouping the objects together to make simpler groups. And I have to take the whole part that is shaded, my numerator and make that 1 or 2 groups or whatever. But I have to make sure that those group sizes are consistent throughout, meaning that you can also divide the whole denominator into those number of groups as well. So I'm going to indicate that with these braces here. And combine these 4 together, and that group of 4 and that group of 4 both make a whole, so it works out evenly. So you take them into even groups, and when we simplify. And because of that, we're going to have a new bar here. And I've divided them into 2. I've taken that 4 shaded parts and the 4 non-shaded parts, and they become two groups, where the first one is shaded. That makes it a half. Okay, so simplifying fractions is systematic grouping. I group them by 2s or by 3s or whatever, where I can do this certain number of groups to take the whole numerator, or the whole shaded part, and then keep going till we evenly get to the whole. Okay? And so that's why this is equal to a half. So my answer for this problem is a half. So 3/8 plus 1/8 is equal to 4/8, and then 4/8 simplified is a half. Okay. So that's how you add. That's how we're going to add our fractions. Our next example is subtracting like fractions. So add like fractions with pictures. We're going to do subtract like fractions with pictures now. Okay. Our example problem for this is going to be 4/5 minus 3/5. With subtraction, we're going to depict the first number, which is the minuend. So I'm going to divide this into fifths, 1, 2, 3, 4. So I make 4 marks. And there's going to be 5 spaces between those marks in fifths. So I'm going to subtract them, depicting 4/5 first. 1, 2, 3, and 4. Okay, so here's 4/5, and I need to subtract off 3/5. Since the pieces are like each other, I can just subtract them off using X cross out. Okay, so I'm going to say, okay, here's my 4/5. Here's my numerical connection, and I'm going to cross out 3/5. Or you can use takeaway if you want. Okay, so cross those off. So I'm crossing off 3/5 there. And the new bar to depict the final amount, the difference, I'm going to draw here. And that final amount is going to be 1/5. All the other ones are gone. Okay. Notice that the 3/5 is not depicted. Because I'm crossing it out, it's an action. Okay. Any questions so far? All right. Now, when we get to so in life, when we have real life situations, the fractions are not going to be like each other usually. So we're going to think about what we can do to add unlike fractions. The pieces, the whole is divided into, are different sizes than the other, and one summoned and then the other summoned. Okay. So we're going to start with we're going to add like fractions. Yeah. Where one denominator can be divided into the other one. Or one denominator is a factor of the other. This is what I mean. We're going to do 2/3 plus 1/6. Okay, 2/3 plus 1/6. Now this is where you get out your little fraction pieces. So everybody got the problem down? 2/3 plus 1/6. Go stop share for a minute. So what you want to do when you want to add these together is you want to pull out the 2/3. So I got 1/3. I'm going to pull these out as I talk. Then I'll show you what I'm doing. Okay. 2/3, 2/3. And I need to add on the 6th. Okay, when we had made our fraction pieces, they were, the lengths were to scale with one another. So, all right, so let me go ahead and share this again. Okay, so I've laid out here 2/3 and 1/6. I need to find the total length. Okay, so these are bar models, they represent length. Now, what's the hard part is that they're not like each other. I cannot express their distance with one fraction. I need to do that. Now, some of you have already worked with these or maybe even know the answer already. So who could guide me about and say which, how I can find out the total length of these pieces?
So if you did like, because 3 is equal to 6, like it fits into 6. And so how many is 1/3 of 1/6? So it would be 2/6. So if you would see how many 6 there are. Okay. And so this is, I drew one. I didn't have the bars.
Okay, great. So what you do is you have your students, so you're right on track, Camille. You have your students play with the fraction pieces. They could be made out of plastic and a little bit easier to handle. And you see how many pieces that you can fit into my thirds so that they're all the same size pieces, okay? So if I have all the same size pieces by placing 6ths down, okay, I can add them together. So these right here are the same as, these 2/3 are the same as 4 of the 6th pieces. Okay? And so if I can exchange them for the thirds for 6th, and then I have all the same size pieces to add together. So 1, 2, 3, 4, 5. 5/6 are added together. And so you have them explore, and you have them maybe do several problems, but we only have time for like this one. Have them do several problems where they kind of pretend or see what the values are for the exchanging one piece for 2 or 3 pieces with different denominators because the whole is divided differently. Once you achieve a representation of the sum of these 2/3 and that 6th with all the same size pieces, then you can add them together and express the total with one fraction. So that's the piece, that's the with the concrete objects. And so with pictures, we can add these together. First by drawing out 2/3 and 1/6. There's my 2/3, there's my thirds, here's my 6. So if we want to do 6, you can divide your whole into thirds. And you can divide those thirds into half, 2 parts, okay, for 6. So this one I'm going to represent with 2/3. This one is 1/6. Okay, so I'm going to go ahead and color those in. You can see the shading there. Okay, 2/3 and 1/6 right here. Now, what we had to do was we had to write them all in the same size pieces. So I'm going to draw a new bar. And this, I'm going to divide into the thirds. And here are my 2/3 shaded. I needed to make them the same size as 6, and all I have to do is divide each piece in half. And as I discovered, right? So now I have 4/6 here. When I'm adding together, I'm combining pieces. So we're going to say, okay, this piece is now going to combine with those 4 and be put right there. When I put them together, they'll become 5/6. And 5/6 can't be simplified because it can't take equal groups out that will fit both the numerator and the denominator. Oops, let's not do that one.
Better not run off. Yeah,
Okay, so now we have 5/6. So that's when, oh, oops, sorry. Mac, going crazy. All right. When one denominator is a factor of the other, what happens if they're not like that? Neither denominator is a factor. Okay.
You have to find the common denominator.
Right. What does that mean to find the common denominator? What am I doing?
So if it was like 9 and 11, the only thing like common with them would be 99. So most times it's you just times that the bottom one by the other one, or if it's like what's one, like if it's like 7 and 6.
Mm-hmm. Yeah, so that's, you're talking numerically what's going on. Let's go ahead and take a look at what a picture would be. And the numerical analysis will guide us. Okay. I'm going to add 2/3 and 1/4. So I'm going to depict my 2/3 here. and depict my 1/4 here. Okay. With Singapore math and with math how it's taught these days, we're looking more pictorially. We can use our little fraction tiles, our fraction bars. So you guys can depict this on with your fraction bars if you want. But for time's sake, we're gonna kind of move on. So we need to depict our 2/3 here. And our 1/4. So here's 2/3. Here's our 1/4. And so when we want to add them together, we need to express them in the same size pieces, which is finding the common denominator. We can't subdivide one piece to fit the other. Subdividing is the word I use to take our fraction, which is already, our whole has already been divided, and we subdivide it, which means we divide it again into systematically. Now we can't subdivide one into the other like we did with the previous example. We need to subdivide each of them into a new whole, or sorry, not a new whole, but a new denominator that's in common between them. And in the homework, you'll read a little bit in the Singapore Math Book 5A. They have an approach where they use multiples to help make this process easier to find a common denominator. So what they do is that they say, okay, 2/3 is one fraction. I'm going to multiply the denominator by 2 to get 6. Okay, and that's what I can do. When I subdivide the denominator into 2 parts, I get 6. When I subdivide the denominator into 3 parts, there you get 9ths, 12ths, and if I subdivide that one into 4 parts, and so on. The next one is a 4th that I'm comparing with. You subdivide that one into 2 pieces, which makes 8ths. Or if you take the 4th and subdivide them into 3 pieces each, you get 12ths. Okay, and when I get the same denominator here, okay, that means that I've subdivided them into the new common denominator. So I'm going to use 12ths. And again, to review, I'm subdividing each third into 4 equal pieces, because that's how much it is to get to 12 from 3. 3 times 4 is 12. Or I have 4 groups here until I got to 12. Okay, I'm going to take each 4th and subdivide it to 3 equal pieces. Okay, if I take each 4th and separate it into 3 equal pieces, then I have my 12ths, which is the same as the 3 subdivided into 4 pieces. So sometimes they are the product of the denominators, and sometimes they're not. Sometimes there's simpler common denominators than just the product of the denominators. But if you use the product, it will always work. So we need our depictions here to change, and we need our bars to be subdivided. So I'm going to draw 2 bars here. And one is going to be the 2/3, starting here. This will be the 4ths. Now, I'm going to take my third and do what I said up here earlier. Subdivide each third into 4 equal pieces. So I use dashed lines to show my subdivision. Okay, so 4 equal pieces means I'm going to divide each part into halves here. I'm trying to use more dots here. And then subdivide those halves in half. Okay, so each piece has 4 equal pieces, and you can tell these are the original ones. These are my original thirds. So I'm going to darken those in a little bit so you can see how that worked out. And so I'm going to darken in here on the 4ths. I have 1/4 And I need these fourths divided into 3 pieces each. And they will match up with what I have drawn above, right? Because that's by design. I want them to match. So you can kind of carry down what you did from above. Now what I had was 2/3. And the 2/3 took up this much space. There's 1, there's 2. But when I subdivide them into pieces, they become, let's see, 2/3 becomes times about 4 each. Okay, that is 8/12. Okay, this one had 1/4. So now there's my fourth, and it became 3/12. So once I've subdivided them, I can show my addition by combining them together. Here is one. I'm going to put these 3 pieces up here into the rest of my room for pieces on the first fraction to combine them together. And then I will show the combined bar here. And since they all became 12ths, we'll keep them in 12ths. So I'll separate this into fourths and each fourth into thirds again to make 12ths. And I have highlighted, or I have filled in up to here all 11/12ths to 11/12ths. So I'm going to shade in all the way to 11/12ths right here. So my answer is 11/12ths. All right. Hopefully that's understandable. Now that we've done adding fractions with unlike denominators, we need to compare the algorithm to what our process was. Okay. This is the abstract part. The pictures and pieces are more pictorial and concrete. They're lower abstraction, but we're going to ignore all the pictures when we add fractions using the algorithm. And we'll use this example of the 2/3 plus 1/4 so we can compare. And we'll note some comparisons. Now, the first thing to do is get a common denominator. And so with pictures, you can take a look at the pieces and divide them up. But with the numbers, we need to change the numerator denominator. We multiply by a form of 1 to change the numbers in the numerator and denominator. Yeah, so I'm going to erase that actually. Put that above it. Okay, so 3/3 is a form of 1, right? Because 3 divided by 3 is 1. So we can multiply any fraction by 1 and still maintain equality. And I was adding on the 1/4 times, whoops. That should be 4/4. Because I took my thirds and I subdivided into each third into 4 equal pieces. Okay, there we go. Now I have 8/12ths plus 3/12ths. That equals 11/12ths. Okay, so here's my process. Now where do all these connect to my diagram up here? Okay, so the 2/3 and the 1/4 in the very beginning refer to the bars up here. Okay. So let me pull this down just a little bit more. Yeah, here's my 2/3 bar, 1/4 bar. That's where these 2/3 and 1/4 connect to. connect to the original bar. I'm going to write this in blue. When I multiply by 4/4, each of the pieces of the 2/3 bar are subdivided into 4 equal pieces. Because I'm multiplying by 4 over 4 because there's 4 times as many pieces now there. In each of those parts. Okay. Similar story for the 1/4 times 3/3. I need to get a common denominator, so I use multiplication to help me because I'm subdividing each of those fourths into 3 more pieces systematically, each fourth. Okay. So each piece, of the 1/4 bar, oh, come on, are subdivided into 3 equal pieces. Okay. And there's 3 times as many in each bar, or in each part of the bar. When I add the 3 8/12 and 3/12, we note that both bars now have the same size pieces. So we can combine them and express this fraction as a sum. Or in other words, we can combine them and express the sum as one fraction, one instead of a group of unlike fractions. Okay. So that's what's great about common denominators and the fact that the structure of fractions help us do this with any fraction that we want. So let's go ahead and move to subtracting fractions. We subtracted like fractions already, but let's go ahead and subtract unlike fractions. Okay, so this will play out a little bit differently than what we did before. Remember that I did not want to depict the subtrahend or the second number because I wanted to cross it all out. But in order to know how many pieces to cross out from the minuend or the first number, we need to kind of depict the second number for a couple of bars here. So our example is 3/4 minus 1/2. Okay. So take a minute and use your fraction pieces to figure out how to subtract off 1/2 or cross out a half. How can we do that with our pieces? Okay, so we start out with our 3/4. Okay, so you can go ahead and put your pieces out. I'll find all my fourths here. 1/4, 2/4. Here's 3/4. Okay, 3/4, and I take away a half. Well, in order to see how much to take away, I can compare it with one of these halves. And it looks like I can take off these 2 pieces because they're the same size. Okay. So I'm going to cross off a half. I'm just going to take off the same amount as this one piece here. They're gone. And I end up with a 4th. Oops. So for time's sake, we're going to keep going. Unfortunately, it gets away from us a lot for our explorations and things. So we're going to subtract these fractions that aren't like each other. And comparing pieces was good. Let's go ahead and depict each one. So we can take off the right amount. So there's my 3/4 here. I've drawn in my fourth. I need 3 of them. Okay, there's 3 of them. And then I need to subtract off the half. Now I'm going to draw half for reference only. Okay, so don't write any subtraction signs, anything like that. We want to show crossing out. You can go ahead and actually, I'm skipping ahead a little bit on that. Yeah, no, that should be, let's see if that, I think that's okay. All right, so I need to take away this amount. And so I'm going to redraw this amount into the amount that is depicted, or the denominator that is depicted in the first bar. So I can subdivide each one of my halves in half to get to fourths. So that makes this easier when I have, unlike fractions where one is a factor of the other. One fraction, one denominator. Is a factor of the other. Okay, so that means I only have to subdivide one of the denominators. Okay, so I'm dividing this into 2 parts, each of those pieces. So my 1/2 becomes 2/4 when I do that subdividing. Okay, so the same amount of space is taken up now by these 2 pieces. And notice that that's what I need to cross out. From my 3/4. And so I'll show my crossing out here. Okay, so those pieces there were crossed out. Go a little bit more precise here. And 3/4 minus my 2/4. And when it's all said and done, I have 1/4 left over. And so those pieces are crossed out. Okay. So hopefully this is good for you guys. Okay. When if neither have a factor of each other, neither denominator is a factor of the other. Like 5/6 minus 3/4. We will depict each one Oops. It's a little bit longer because we're going to do big numbers here. Okay, so here are my 6th. And I need to subtract off 3/4. So I need to depict this next whole into 4th. Let's use this one. Okay, so here's my 5/6. Any recommendations about how to subtract 3/4 from there? Oops, I need one more 5th. 6th, I mean, one more 6th here. Okay, so any ideas of how we should subtract these? You will cross out this distance here from up here. Is this stuff pretty trivial, or guys just feeling shy?
Wouldn't you find a common denominator that you could split your top one into
Yeah, you got to split the top one and the bottom one.
and the bottom? Yes.
Yeah, because I'm keeping track of what my second number is in the subtraction problem, so I know how many pieces to take away from the first
Yes.
number.
Yes.
Okay, great. So we need to split them up, same size pieces. Okay. Let's see, how did we do that? Okay. We wanted a common denominator, that's what it's called. With 6th and 4ths. And so we do our 5/6 here. We kind of list them out. 12ths and so on. We also have our 3/4, some number of 8ths, some number of 12ths. So that's good that it didn't go very far there. Okay, so our 12ths are a common denominator. We're going to split each 6th in half. we're going to split each fourth into thirds. Okay, so that's how we're going to do that. And we'll show that with new bars here. So I needed to do my 5/6 here. I needed to go into 12ths. So I'm going to split each 6 in half. So that means each fifth, the 5 parts that are 6 also be in half. So I'll have 10 of those. And I need to split my 3/4 into 12ths as well. And there'll be 3 of those, so it'll be 9/12. And so 5/6 I'll show right here. And I'm going to split those in each of those in half. Okay, so I have 2, 3, 4, 5. Okay, so now I have 10 pieces here. And then in my 3/4, I'm going to split each of those into 3 parts. Each of those fourths into 3 parts. And they should line up nicely with your top one, but my drawing's a little bit off. It's okay. And I'm highlighting my 3/4 here. Okay, so my reference bar indicates that I need to cross out 9 of those 12s. Let's go ahead and cross those out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so what I have left over now is just one of those 12s. I divide my bar into 12, so I have halves. This will be 6ths. This will be 12ths. Okay, so I have just one of those left. Okay. So that's how we subtract with pictures. Subtraction numbers that are unlike each other. Any questions so far?
On our assignments, do you want us to be drawing out the reference bars?
Yeah, it's probably helpful to do that.
Okay.
But you want to you don't want to show any subtractions. You want to just do cross out or something, or take away.
This is unrelated, Dr. B, but just
Yeah.
to let you know, I think we might have forgotten attendance.
I was waiting till the end. Yeah.
I was trying to be helpful.
No, because I did forget on Fridays, a couple Fridays already. But I do have my paper out, so let's go ahead and pause here and stop this here and take attendance. So I appreciate that. Okay. The last topic is just adding and subtracting mixed numbers. Oh, actually, no, we got to do the algorithm. So thinking about subtracting using the algorithm, and then we'll do add, subtract, mixed numbers. Then we'll be done for today. So we're going to subtract fractions. Using the algorithm. So we want to connect back to our picture, so we're going to use the same problem.
Your iPad's not showing, by the way.
My what?
The iPad's not showing right now.
Oh, got to share it. Thank you. So we want to subtract fractions using the algorithm and connect it back to the pictures so we can see the importance of why we do what we do with the numbers. Okay? And that's what's tricky for students. If we want to subtract with the algorithm, we need to use find common denominators. But one very key thing is that students, if they don't have any reference to pictures, they will mix up all of the algorithms for operations with fractions. Okay? They will want to find common denominators when they multiply or divide, which you can do, but it'll take longer. They'll want to multiply the reciprocal when they add. So that's the tricky part, is that you cannot multiply the reciprocal or add the reciprocal when you're adding fractions. That doesn't work. Okay. Eventually, you can use different algorithms with multiplying and dividing fractions, but it'll take longer to get there. So we don't want them to mix it up, and so that's why we have to connect using pictures. So if I have 5/6, we've done work with what 5/6 is, and we've done work with what 3/4 is. If we want to subtract off the 3/4 from the 5/6, we use our pictures and we use our little fraction bars to help us. Okay? We don't want to get these all mixed up, and that's why we're doing math in a different way with the core standards than what we did before. Okay? So some of you who have learned fractions from before the core standards, you might still kind of wonder, like, okay, should I do common denominators or what? Or should I multiply reciprocal? So now what we're doing is we say, okay, we know what 5/6 looks like. We know what 3/4 looks like. We want to subtract them. We need to find the same size pieces in order to take them off. Okay? And so what we do that with numerically is we, take our 5/6 and we need the same size pieces. We found out they were 12ths. So I multiply 6 by 2 to get to 12. And you can subtract off 3/4. Change into 12ths, multiply by 3 over 3. Okay. So that's going to equal 10/12, subtract off 9/12. And when I do that, I get 1/12. Okay. I can't do it that way. Let me go and rearrange that. So I forgot I wanted to make some notes here. We need to make connections to our algorithm, or from our algorithm to our pictures. Nope, something happened here. Here comes 3s. Okay. So these 5/6 minus 3/4 are depicted in the original bars. The 2 over 2, why we're multiplying by 2 over 2 is because we need to find the same size pieces. So each piece of the of the 5/6 bar is subdivided in half. And with the 3/3, we multiply that by 3/4 so that each piece of the 3/4 bar is subdivided into thirds. Okay. Now what we have is new bars that are different size, have different divisions in them. That's 10/12 and the 9/12. And so the original bar and the amount to be subtracted now have the same size pieces. So we can cross off those pieces and express the difference as a fraction. One fraction. Okay, so that's our whole goal, is to be able to express our sums and differences as one fraction. So we're given two fractions, we combine them together, express them as one fraction. And that takes a little bit of, it's a little bit tricky at sometimes to do that. Okay, so just 1 second, I'm gonna plug in my iPad. And as I do that, we're going to talk about adding and subtracting mixed numbers. So we're going to do adding mixed numbers. Okay, so our example to add, we're going to show it in a couple ways for each one, adding and subtracting. Let's do 4.5 plus 3 2/3. I want you to add those according to the algorithm and maybe another way. So go ahead and try that out while I plug this in here. See how to add those together. And whoever's got an answer, let them share out.
So I got 8 1/6.
Great, and how'd you do that?
So I looked at the 2 and the 3 and figured out which one, like those are both equal to with the bar models or the fraction pieces. And they both work with 6.
Mm-hmm.
And so to change them into, it would be like 1/2 is 3/6 and then 2/3 is 4/6. And so if you add those together, it's 7/6. And so it would be the two fractions together would be 1 and 1/6, and then you'd add the whole 4 and the whole 3 in.
Okay, great. So what you've done is you've described the Singapore math way, where they do take care of the whole numbers and then they take care of the fractions. Okay, so I'm going to do that way. That's going to be way number 2. Not going to for our notes. Way number 1 is using standard algorithm, which means that I convert everything into improper fractions and add those. So let's go ahead and do that real quick. 2 times 4 is 8. And so changing them, as a reminder, changing them into mixed numbers, you multiply the denominator by the whole number, and you add that to the numerator. And then you put everything over the denominator. So 2 times 4 is 8 plus 1 is 9. 3 times 3 is 9 plus 2 is 11. Okay, so I need to get 6, like was mentioned here as well. And to get to 6, I did 2 times 3, so 9 times 3 is 27. 3 times 2, and 11 times 2 is 22. So 27 and 22 make 49 and over 6. Now I know that I can leave it like this or as improper fraction, or I can change it to a mixed number. Depending on my context, either one will be correct. So 49/6 is equal to, if I divide it, 8 and 1/6, because 6 times 8 is 48. Okay. So way number 2 is what Camille was saying. 4.5 plus 3 2/3. Now, the numbers 4.5 are actually addition, 4 plus 1/2. Okay, so that's equal to 4 plus 1/2 plus 3 plus 2/3. If you wanted to expand it out like that, that way you can use the commutative property and switch these two, and you can add them together. It's 4 plus 3 plus 1/2 plus 2/3. Make that 7.5 plus 2/3. So what the Singapore math does, it just goes ahead and adds these two together. The 4 and the 3 become 7. And then they just keep the 1/2 and the 2/3 along for the ride. So that means 7 and 3/6 plus 4/6, which is equal to 7 and 7/6. Now the 7/6, you can break up into 6/6. Let's put pluses here. And 1/6, and that 6/6 becomes a 1. And then that's where you get your 8 and a 6 from. Okay. So I showed more work on this one, but mentally you can do it faster. Okay, if you wanted to do these mentally. All right, so that's how you add mixed numbers. So we got 1 more minute to do subtracting mixed numbers. And if you need to go, that's okay. I'll post the notes and the lesson plan on the course calendar. But the last topic is subtracting mixed numbers. And there are 3 ways to do that one that we'll show you. So our example problem is going to be 5 1/3 minus 2 3/4. What they like to do in Singapore math and on fluency tests is they like to put the fraction part of the second number or the subtrahend to be bigger than the fraction part in the minuend or the first number. And so we need to do some regrouping in order to handle that. But first, the standard algorithm says we convert to mixed improper fractions and just subtract that way. The way number 1, way number 2 here, was seen coming. Okay, so way number 1 is this standard algorithm. So 5 1/3 subtract 2 3/4. That's equal to 5 times 3 is 15 plus 1 is 16/3. Subtract 4 times 2 is 8. 8 plus 3 is 11. 11/4. We get our common denominator of 12. Then 3 times 4 is 12. 16 times 4 is 64. 4 times 3 is 12. 11 times 3 is 33. And so our 64 minus 33 will give us 31 over 12. If you want to make that a mixed number, 12 times 3 is 36. No, that's too big. 12 times 2 is 24. And the difference is between 24 and 31 is 7/12. So that's the standard algorithm way. Way number 2 is Singapore math way. And again, the Singapore math is they take care of whole numbers first, then fractions. So if I have 5 1/3, subtract 2 3/4, you can subtract the 5 minus the 2. Okay, so there's a little bit more to that equation, but I'm going to skip a little bit for time's sake. Subtract the 5 minus the 2, and now you just have to subtract the fractions. So let's get a common denominator. 3 and something over 12 minus something over 12. So that's 4/12, subtract 9/12. So that's what they like to do in these problems, is they want to make the second fraction bigger. So we have to do some regrouping. And what we're going to do is we're going to take 12/12 away from the 3. That becomes 2 plus 12/12. And we can take those 12/12 and add them to the 4/12. When I do that, I have a new number that's in a different arrangement with the same value, and it's 2 16/12. Now I can subtract off 9/12 from that. It gives me the 2 7/12. So here, this might actually have a couple of advantages over the standard algorithm, as the numbers are simpler to use. You don't have to do lots of multiplication. Now, way number 3 is also a fun way. It's called the counting up way. So if we want to do 5 1/3, subtract 2 3/4, we start at 2 3/4 and we count up to 5 1/3. So I'm going to add something to 2 3/4 to get to a nice number. Let's add something to get to 3. And when we add something to get to 3, that would be 1/4. Okay. I'm going to add something next to get up to 5. That means I added 2. I'm going to add something next to get up to 5 1/3. That's going to be 1/3. Now the difference between 2 3/4 and 5 1/3 is whatever these are added together. Okay? So we group them together. That'll take actually a little bit of calculating on our part here. We're going to add 2 plus 1/4 plus 1/3, which is the same as 2 plus something over 12 plus something over 12. That's 3/12 and 4/12, which gives me my 2 7/12. So everybody got that okay? Any questions? So in the homework, I showed you, you can just do one of those 3 ways. I showed you 3 to give you some choices.
Professor Broadwick, is this what you mean, looking at the homework problems right now, is this what you mean by one of the models? Those 3 ways?
Okay, which problem are you on?
I'm looking at 51 right now, just for reference.
Now 51, illustrate the following using models shown in class. Yeah, so the models are the fraction bars or drawings of them. So yeah.
So just put the pictures of those?
Yeah, so just how we did it just now. You put the pictures, you show the steps. If you have to do any common denominators, you want to show the bar that's subdivided in a different way than the original problem. So we subdivided in additional divisions.
And then for the summary section, there's 3 different problems from the primary math. Do you just want like a roundabout
So which one you
illustration
talk
of what
about?
it means?
Which number?
Number 52, summarize the use of thought.
Oh, the thought bubbles.
Yeah.
Yeah, so I mentioned what the thought bubbles were about adding and subtracting fractions. When you have common denominators, they use multiples to help get those denominators to know how many to subdivide them into. That's kind of what the thought bubbles are mostly. So they'll have like drawings of students where they have thinking like, oh, I'm going to do multiples of 4 to get to 12, and multiples of 3 to get to 12. That way I know that 12 is going to be my common denominator. I kind of listed them out in the notes here by listing out like something over 3 and something over 4, and then finding multiples to get up to 12. Any other thoughts? Those are great questions.
No, but I gotta head out. Thank you so much.
Yep, you're welcome. Have a great day.
I also wanted to know if possibly after class I can go over my scores with you that I found in the grade book.
Okay, that'd be fine. All right, so I'm gonna go ahead and stop the